video, we have installed the containerd on every machine which is going to be created or which is involved in cluster creation to master workers. We have installed the containerd, which is a default runtime, which is we are going to use it in our cluster. So container runtimes, which we have installed it already, and we have seen out of this containerd is the one which we have installed it, we have configured it, and currently it is running absolutely fine. Now we will proceed further and we will go to the next documentation called as installing Kubernetes with deployment tools. If you go to this installation documentation, there are three methods are mentioned to deploy the Kubernetes cluster. The first method is kubeadm, second method is a cop, third method is a kubespray. Correct. Now out of this we are currently using kubeadm method because we are doing everything on premises at this moment of time. So we are using our own virtualization and everything. So we have a full control on it. So we will see how we can set up multi-master cluster with the help of kubeadm method. In the next upcoming videos, I will show you how to implement kubespray also. What is exactly the method of the kubespray implementation is available. But currently we will go with kubeadm method. So if I click onto the kubeadm documentation, so many documentations are available. Okay, if I want to create my cluster with the help of kubeadm, so basically what is kubeadm? Kubeadm is a utility. It's a cluster manager, you can say. With the help of this utility, you will be able to manage multiple cluster related activities. So if I would like to reset the cluster, if I would like to add any new worker, if I would like to add a new master inside my environment, correct? So cluster related activities, if I would like to upgrade my cluster, downgrade my cluster, there are so many activities which kubeadm can do. So technically kubeadm, it's a utility which we can use to create a cluster, correct? So if I would like to use kubeadm utility, then first I have to install this kubeadm utility on your machine. After the installation of the kubeadm utility, we will use this utility to create a cluster, correct? So the first documentation which we are supposed to use to installing kubeadm at this moment of time. So I click on to the installation of kubeadm. Once again, if I using any older version of Kubernetes, I could have a proper documentation available over here. But currently, whatever the latest version of the kube ADM utility would be 1.30. So whatever Kubernetes cluster which we are going to use it, it's 1.30 because my kube ADM which I am going to use to create the cluster would be 1.30. Correct? So before you begin, here is some of the prerequisite needs to be configured before you proceed further. Now we have done all these steps, swipe configuration, correct? You are supposed to do everything. So everything should be uniquely your machine name, your MAC address, whatever prerequisite which I discussed with you earlier video. Same thing would be available over here also in document. I would request you that you can read this particular documentation very well. Now here there is one important point which I would like to discuss with you. I told you that firewall should not be disabled. There are certain port number you are supposed to be open. So what are those port number you are supposed to know? So here is certain port numbers supposed to be open on your machine, but we do not uh, use the firewall, so you really don't need this particular pointers to be done. But I told you in a production environment we are not actually using disable firewall feature. Means we are not going to disable the firewall. So here is the documentation. If I right click on it and open the new tab, okay, you can see this is the required port numbers are available. Now control plane is another term which may be coming to your curriculum, or you can say in the discussion in upcoming session, control plane means your master. Okay, control plane is nothing but your master. Master can also called as control plane node. Correct? So on the master, these are the port number you are supposed to make it open. If you are not going to disable the firewall, if you want the firewall to be turned on, that is necessary in production environment. So you have to make sure that whatever control plane which you are using, in our case there are two masters. So I have to repeat all these port numbers, or I have to open all these port numbers on that machine actually. Right? Similarly, on worker side, these are the port numbers. Means whatever worker nodes are available, these are the port number you are supposed to keep it open. Correct? So in production level environment, this is a necessary steps you are supposed to do it according to the documentation. These are the port number you need to open it. Correct? But in our case, we really don't need to bother about it because we disable the firewall. Correct? So we have disabled the firewall, we have done this unique name step, we have a full network connectivity, we do have a 2 CPU, we do have a 2 GB RAM, and we do have a proper Linux, which is a certified Linux. Swipe configuration, you can see. If you would like to get more details about swipe, actually I would request you for swipe memory management, read the proper documentation, what impact would be happen in terms of swipe on the top of Kubernetes functionality that will be available over here. Okay, so I will scroll down the page, and these are the same documentation they have repeated in order to verify whether whatever prerequisites are available, those are done. Now, installing container runtime is one of the prerequisite according to this documentation, and we have done it. Correct? Okay, so if I scroll down a little bit, now these are the three utilities we are supposed to install it on your all the. Okay. Now Kubevadium is a utility which is nothing but a cluster manager, or it is a utility, or this is a software in a simple manner which will help me to build my, not just build, it will help you to reset the cluster and destroy the cluster also. It will help you to upgrade your cluster. Kubelet, this is another important component inside your architecture. You know that what is the purpose of the kubelet. Kubelet is a very important component, or it's a mediator between your workers and your masters actually, as well as it is a mediator between your container runtimes and your particular API service. Okay, so technically kubelet will play a very important role over here. So we are supposed to install the kubelet also. Now it's a client utility. Technically, uh, uh, it's a client utility to connect with the cluster. Now normally we are going to install this utility on a machine where from where you want to connect it. Correct? But for the time being, we are going to install this utility on every machine. Maybe that in future, if I would like to connect from any part of the cluster, I could use it. But technically, only two software is currently necessary to install on every machine. One is called as Kubeadium and Kubelet. Kubectl is fully optional. Okay, but it is a client utility for our testing purpose. I would like to install it on every machine just for that, but in reality, kubectl or kubectl utility only can be installed on your machine from where you want to connect. If I scroll down a little bit, here is the documentation and other necessary information is available over here. Okay, so there are two type of packages are currently available: Debian based and Red Hat based. Debian based packages would be available for Debian, Fedora 1.2, and Red Hat based packages would be available for CentOS, Red Hat based operating system. Now once again, here is the same repeated step, that if you would like to install anything, your SE Linux should be permissive. We have already done this particular step as a prerequisite, so no, not to worry about this step any further. You can scroll down a little bit. Now according to the documentation, this is the repository which I would like to add on every machine. Okay, so I will copy this entire set of command. I will minimize this page and I will execute on the master one, master two, worker number one, worker number two, and worker number three. So what I have done on all the machine, I have just added the Google repository. Okay, this repository location from where I will download all these packages. Okay, now I will install these packages on every machine. I told you kubectl is optional. The most important is the kubeadm and kubelet. Correct? I know these two important installation necessary to be happen on every machine. Kubectl is optional, but I told you I'm going to install it on every machine. Maybe that in future, if I would like to connect any of my worker to connect with the cluster for testing purpose, I could do it. But currently, these two are only important. Okay, so I will go ahead and copy. And here is one more interesting argument they have mentioned: disable exclude is equal to Kubernetes. Remember that whenever your system update is happened, your system will not update this particular packages. You don't want to do it. Okay, means automatic update if you are applying it. So it is necessarily mentioned disable excluded. That means you are update your system with the help of yum update command, but it won't update this particular package. I said okay, no problem. So I will minimize it. I will start installing on master 1. I will start installing on master 2. I will start installing on worker number 1. I will start installing on worker number 2. I will start installing on worker number 3. Correct? So you can see at this moment of time, I am parallelly doing installation of kubeadm, kubelet, and kubectl. Kubectl is technically optional, but I am installing it on every machine at this moment. Okay, now I am installing all these packages at this moment of time. So it will take a couple of minutes. It is done. It is done on worker number 2 and it is done on worker number 3. What is the next step? The next step is to enable the kubelet. Now currently kubelet process is not going to be running on your machine, but I just need to mark that particular process to be enabled. Means if I turn off the machine and turn it back on, kubelet process and containerd process needs to turn on automatically. Currently kubelet is not running on your system. We just mark that particular process to be turned on whenever you reboot the system. Now when kubelet will actually start? Whenever you create the cluster, okay, your cluster will provide some information to start your workers. Okay, whenever you are joining the workers actually, then only the kubelet will start. Kubelet requires some configuration to be available with him because he is interacting with the API server. He requires some certificates for authentication, correct? Authorization. So there are many configuration component required for kubelet in order to start the process. Currently that configuration is not available and that configuration only provided by your cluster. So currently cluster is not up. That's why you don't have the configuration, and that's the reason kubelet is not going to run at this moment of time. Even if you try to start it, it will not run because he's looking for, correct? Now my installation of kubeadm and my installation of my kubelet has been successfully done over here. Correct? Now I will minimize this window one by one. Okay, and we are supposed to go ahead and go to the next documentation in this list. It's called as creating a cluster with the KubeADM. We have followed this documentation installing KubeADM. So we have installed the KubeADM software already. Now we are going to create a cluster over here. And if I go here and create the cluster documentation is available. Now we have everything necessarily set up as it is. Now this is a good time, or you can say this is a right time that all the prerequisites are completed. You can create your cluster at this moment of time with KubeADM. Once again, if you refer this documentation also help you what you are supposed to do, what are the prerequisites. Once again, same story which is coming up. And finally, it is going to show you a very simple command over here that is called as kubeadm init. Init stands for initialization. Now remember that till so far I was talking about that every command has to be executed on all the machines. Installation, configuration, starting the service. Okay, all the settings has to be done on every machine till so far. But bootstrapping or creation of the cluster should be happening on the master. Okay, now we are going to create the cluster. We are going to create the cluster. Now we are supposed to create the cluster. Now whatever cluster creation commands are available, you are supposed to execute that particular command only and only from the. Now people ask me, I have two masters, which one of them? You can choose any one of them. Okay, you can choose any one of them. Correct? Any cluster related command, you can choose any of the master. Either you can choose master 2, then you can join another master into the cluster, no problem. Any other master you can choose to execute. But now whatever initialization related command should be happened or it should be executed, it is executed only and only from master. Remember, correct? So here I am actually going to use master number 1 in order to initialize my cluster. Okay, this is the execution. From here I am supposed to execute a command called as kubeadm init. This is a single command who can initialize my cluster. Okay, but if I execute the command like it is right now, it is going to execute all the necessary action to create the cluster. Okay, whatever default settings which you required for your cluster, he will take all the default setting and he will go ahead and execute your cluster over here. Correct? But if I would like to customize some settings while creating the cluster, then my kubeadm utility provide me the arguments over here. Now what argument which I can pass with init command, if I execute --help option over here, you will come to understand what are the different type of argument which you can pass inside this or to this particular kubeadm command. Okay, so you can see this is so much number of arguments are available. API advertise address, API bind port number, correct? So these are different arguments are available, and every argument, okay, every argument should have their own setting configuration. For example, I am using API server. API server is the most important component as we know in a Kubernetes architecture. So if I would like to specify a particular IP address to be used for API server of the Kubernetes, I can provide this argument along with that particular IP address. I could use it. If I want to use it for API server, I can use it. Correct? Now, according to that, there is a very interesting option which is available over here. Control plane endpoint. Now we are supposed to provide this argument. What is the argument option? Control plane endpoint. Specify a stable IP address or DNS name for control plane. He said stable IP address or DNS name for my control plane. Control plane means master. Now why we are supposed to use this option? Why he is asking for stable IP address? If you look into the diagram, we have two masters over here. Okay, so my client can go to this master, connect with the cluster. My client can go to this master and connect with the cluster. Correct? So technically, if I look into the IP addresses, there are two different set of IP addresses for two different masters. That means there are two different control planes. Correct? So is it a stable IP address? No, technically, if this client want to connect, he can either go to this particular control plane or either this will go to the control plane. But are they stable IP address? Because sometime you might be going here, sometime you might be going over here. So this is not a stable IP. So which is your stable IP address? This one. So my client rather going to him or my client rather going to this IP address, my client should go to this stable single IP address. My client will go to this stable IP address which is 192.168.226.50, and the same IP address I will tell to my cluster, this is the IP address which is a stable control plane IP address. Remember that. So whenever your cluster would be created, your cluster will remember that, oh, your control plane is working on this. But is it a control plane IP address? No, it's actually load balance. We are just creating an endpoint, which is a stable endpoint, which is identify your cluster. Correct? So here I have the command written in this way. So I will explain you this command in this way. Okay. So this is the bootstrapping command. We will get one error over there. That's not an error, but it's a warning. So you can see this is the command which we are supposed to use it in order to execute, in order to create my cluster. The first argument I am going to pass it. This is control endpoint. This is a stable IP address which you can configure it for your cluster. Second is upload certs over here. Now if I go upload cert, upload control certificates to the Kubernetes secret. Now you know what you mean by secret. So upload certificate as a secrets over there. Now there is a reason behind it why we would like to upload all the certificate as a secret to the cluster. Then you should have API advertise address. Okay, he said, okay, control plane means your master is this or your control plane endpoint is this. That means everybody should contact with this. This is the IP address. But what is your API server advertise address? Now this is fully optional. Even if I don't mention this, that is okay. But sometime what happens, whatever Kubernetes cluster which you are creating, that particular cluster may have, out of that, which one you want to use it or which one you want to advertise it as an API server, that you have. Now in our case, I don't have multiple network interface on that master. Correct? So here I have declared this API server advertise address. This would be the API server IP address. Even if you want to create this endpoint should forward it to this particular advertise. So this is the actual complete command which you are supposed to execute on the top of your master only, and this is one of the master which I have selected. Correct? Now if I press enter over here, you can see this is the warning which I was talking about, but that's okay. There are two chances where you are getting the error. The first chance would be under this pre-flight check. Okay. Second chance I will tell you when you are going to start Kubernetes service actually. So there is another chances why you are supposed to get an error. You can see right now it will take some time because it's trying to pull all the necessary images for your Kubernetes cluster. It will not take that much long also. It will take 2 to 3 minutes in order to create it. You can see it's proceeded. Now he is doing certificate generation. Configuration. Okay. Now kubelet check. Now here you have to be very careful. If you have done all the necessary things properly, you would be passed through it. We are just waiting everything. My cluster is up. Okay, that means my first master is up. Okay. Now you can carefully check there are few steps. Now your Kubernetes control plane has been initiated on this particular master at this moment of time. Okay, so this master is currently up. Now if you carefully check, there are two join commands they have mentioned. Now you can see you can join number of control plane with the help of following as a root user. That means we have another master available, correct, which is master 2. If I would like to join that particular master as a master, I would like to copy this entire command as it is. I will go to the master number 2 and I should paste it. I would like to add one argument over here additionally. Once again, that is not compulsory, but for a safer side, I am going to use this argument on master number 2, and this argument should be the IP address of that API server. Now once again, logic is same, that if you have only one network interface IP address, it's okay. But for a safer side, I am declaring my API server. Okay, this is the IP address which you are supposed to use it for your specific advertising as a API server. Now I will press enter. Now this is my second master. Remember that this is not a worker. This is my second master which I am initiating it with the master join command over there. Now wait for some time. Now here also there is a small glitch. I hope I am getting for a while, but I am pretty much sure it will resolve all the necessary action, because this is also a control plane. This is also another master which we are planning to implement. My first master is ready at this moment of time. My first master gave me this command and tell me that if you would like to add another master, please execute this particular command over here. I said yes, I have another master. I executed the same command with additional argument is this one. That is the only additional argument which I have passed. Now I am going to execute the same command over here. Now he will also take some time because this is also a master. Now we will wait. Okay, so it's proceeded. Okay, this was a glitch, okay, which I was talking about it. Okay, so you can see it's done. Okay, waiting for a join. This will take up to 40 seconds. Update status deprecated will remove the future release. Okay, so currently your particular cluster has joined your second master house. How do I confirm it? It's joined it. So you can see there is three command they have given. Now you can see here they have not given you any additional information. Only these three commands they are going to talk about it. So I said okay. I will execute these three commands from here. No problem. I just want to confirm whether this particular master has been joined or not. So if I execute a command kubectl get nodes over here, you would be able to see there are two control plane which is currently not ready. So I am successfully able to join two masters to my cluster at this moment. Currently the status is not ready, that's okay, because networking drivers are not installed. That is the reason behind it. Correct? I said okay. So my second master has been successfully joined and my first master is already initiated. But what about worker? How we can join the worker? Don't worry. On your master one, where we have done the initialization for the first time, they give me another join command over here for my workers. Okay. So I copy that join command from here. Now this is the join command for master. Remember that this is for control plane. And this is the join command which I would be using for my workers. So I will go ahead and go to my workers one by one. So this is my worker number one. I will press enter. It's done. So I will go to the worker number two. I am executing the same command. My worker is joined. I will go to the worker number three. Execute the same join command. Done. So if I go to my master 1 or if I go to master 2 anywhere, I really don't mind. Okay, I just want to execute this three command on master 1 also because I am going to copy the admin.conf file. Okay, sorry. Okay, now from here kubectl get nodes, you would be able to see all my workers has been connected to my cluster and all my masters is also available. What I can do it, I will copy this entire segment and I will paste it as the output here. Okay, I will do it. I will say control N. So if I say kubectl get pods, sorry, get nodes minus go wide, you would be able to see all my workers and all my masters would be the part of the cluster. Currently the state is not ready. That's okay. No problem. I would like to see the control plane pods, how they are working. If I say kubectl get pods minus n cube hyphen system over here, you would be able to see, I will provide minus o wide. You would be able to see there are two API server, there are two control manager, there are two schedulers, there are four proxy server. Now you can see this API server is working on master number one, the another API server is running on master number two. So that means whatever masters which is available, you would be able to see two number of API server, two control managers, two schedulers, but those schedulers are working on that respective masters over there. Correct. Now same output if you go to the worker master number two. Okay, some people say that sir, is it only for this? No, you can go ahead and say kubectl get pods minus o wide every master minus n cube hyphen system will get the same, correct. So my cluster is right now ready to use it, but there is only one step is pending. Now you would be able to see your status is saying not ready. The reason is very clear that your networking drivers or networking plugins are currently not installed. And you can see DNS has not been established yet. Okay. So currently the DNS is not running. And the DNS is not running. Why? Because your networking drivers are not there. So what networking drivers we are planning to use it? We are planning to go for Calico networking drivers. So when we go for Calico over here, Calico is a third party networking plugin. As you know that Kubernetes natively don't have any networking drivers developed by themselves. So they are dependent on third party networking driver, and project Calico is quite interesting networking driver which we have. Correct. So if I go to the product over here, okay, we would like to go for installation document. So, customer, best is what we can do it. We will say install Calico. So you would be able to see if I go for install Calico, they will directly go to this documentation that install Calico networking and networking policy for on-premise. Now currently whatever we are implementation which we are doing, it's a kind of on-premises because we are using virtualized environment. So if I click onto this install Calico networking, so Calico also come with two different flavors right now. There is a operator concept and there is a manifest concept. I would like to be very much comfortable with the manifest concept. So I will click on manifest over there and I will install Calico on Kubernetes less than 50 nodes. Okay, so this is the documentation available. So this is the URL. I will copy this URL, go back to my master one. I can execute this command either from master one or master two, doesn't matter, to be honest with you. I will download this. Okay, I will go ahead and see Calico YAML file is downloaded. Right now I will say kubectl create -f calico.yaml. I can execute this command either any of the master, doesn't matter, because right now they are same, they are on the same cluster. So if I execute right now everything, so it will go ahead and create all the necessary component which is really required for networking over there. And I will go and check my all the networking related components are running fine over the cluster or not. You can see one Calico is running on master one, some of them is working on worker number one, worker number 2, worker number 3 calico is there, and in one calico is also available. Now calico will take some time to get implemented because he is pulling all the images, all the necessary images. Then he will do some initialization task. Okay, you can see slowly it will start initializing everything. This is a networking component. Now we have a special training on Calico actually. If you want, there is a dedicated 2-day training only on Calico. How this networking is actually working, what is the procedure of that networking, everything would be considered over there. You can see it will hardly take 1 more minute to start your Calico also. Once your Calico is ready, your pending DNS server will also get ready and your cluster will good to go. You can see one of them started running, but it's still not ready. Second one started running, but still not ready to go for networking. This one is also started running. This should be ready plus running. Okay, 1:1. So this is something which we are waiting for it. You can see slowly it's ready and ready. Okay, it's taking some time. Okay, all the pods are running absolutely fine. We are waiting this particular pod, and this particular pod will get ready actually. Okay, they are all ready right now. You can see my cluster is currently completed all the process, all the control plane components, all the architectural components plus networking components are running absolutely fine at this moment of time. Now if I go ahead and say kubectl get nodes -o wide, you would be able to see all my masters and all my workers are in a ready. If I would like to execute any particular pod right now, for example, let's say I would like to run the pod. So if I say kubectl run my pod hyphen image is equal to nginx, enter, my pod got created. Let me see kubectl get pods -o wide. It would be scheduled to worker number 2. Currently the container creation would be happening. So if I go ahead and describe this pod to check what he's doing, so kubectl describe pod my pod, you would be able to see he might be pulling the nginx image. You can see this, correct? So right now my cluster is up at this moment of time. All the necessary nodes are running. So this is a multi-master setup. Remember that. If this master goes down due to some technical reason, I do have an alternate master available at this moment of time. Now remember that all my requests are going where? To this master or this master? How do I find it out? Simple. I will just go ahead and say v is equal to 6. I just want to verbose output. I want to find out where this request is going to, master number 1 or master number 2. So you can see your request is going where? This is the IP address of your load balancer. So technically where the requests are going, this is the end point of your cluster. So where the requests are going, the requests are technically going to this endpoint. Internally, this endpoint will go and replace this endpoint with one of the master IP address, and internally he will go ahead and do all the activity and give the result back with same IP. So where it's pointing, it's pointing to my IP address of the load balancer, correct? And from there it will go to one of the master to proceed your, correct? So currently my cluster is up, correct? Okay, my cluster is up to date, no problem. My all the nodes are absolutely fine over here, correct? And I am able to run my application workload on worker number 3 as a demonstration which I have shown you. It is also running absolutely fine. So my multi-master cluster setup is currently ready. Okay, so we will stop it over here. Now we will discuss few more pointers over here into the same series, and we will try to give you some more idea about how this multi-master setup will work over there. Till we will stop the video over here.